discuss on the topic of handwritten digits detection. So previously, if you wanted to transfer money from your bank account to another person's bank account, you would have to first go to the bank. Then you would have to fill in the check with the required details, bank account number, amount to be transferred, your signature, address of the receiver's bank, etc. After you have completed the form with all the necessary details, the bank teller checks that that you should not have left any information blank, and if you have used the proper format. After this, the check is approved and you get a slip, which is your proof of having cashed the check. Finally, the check is cashed in, meaning the transfer is complete. However, when the lockdown due to COVID-19 happened, banks realized that they would have to find another way for their customers to be able to cash in their checks, since going to the bank was not possible. So they decided to make it possible for a customer to transfer money from home. They did this by creating an application. This method is called net banking or e-banking. So with every bank releasing its own apps on the Google Play Store, you can just use the bank's mobile application to send checks from the comfort of your own homes. How this works is that first you have to fill the check forms with the required details. Take an image of your check and upload it to the application. The application then scans through the check to verify the information. Bank account number, amount to be transferred, your signature. It takes all of this from the image and then verifies it. Once the verification is successful, the check is cashed and the bank balances are updated. You are given an electronically generated receipt which confirms that you have made the payment from your end. So, how was this change bought? How is the application able to take the important information and verify it from just the image of the check? The answer is computer vision. Computer vision is when a machine or computer is able to see and understand what it is seeing. It first acquires a lot of images or real time video, then it processes that data by using these images and videos with their labels. Label simply means the answer. So, in case you are creating an object detection uh, model, the labels will be the answer. Simply, they will be the name of the object present in the image. So, by comparing these images with their labels, the the computer vision model learns to identify objects accurately. So, as the machine can now identify objects of an image, there were endless possibilities that were previously unthought of, which could now be explored. So, what are the overall use cases of computer vision? Computer vision has many use cases. Firstly, by analyzing bank checks, it can get the necessary data and verify it before cashing it. This helps save time and energy of the customer. It can evaluate any type of form to get necessary details from them. For example, at airports, instead of having your passport checked by a human, a computer could go through your document. The computer will be able to do so much faster, and it will reduce waiting time, and long queues will be a thing of the past. Computer vision can be used to decode barcodes on packages and verify them to prevent mislabeling of products and checking of expiry dates. It can also check if the package is damaged. This will help improve the quality of products. In case of grocery shops, Amazon has released a new franchise of shops known as Amazon Go, where you can self checkout. Using computer vision, your bill will be created and sent to you digitally. You don't need to stand at a checkout counter and wait for your turn so that you can have a bill. The computer vision model will see what you are taking and add up the prices, creating your bill. This results in a fully automated store where no human workers are employed. In this video, we will be creating a computer vision model which will use convolutional neural networks to identify handwritten digits. The code of this project can be modified to fit several use cases. Now let's address the challenges that we will be facing in this project. Firstly, the amount of data or space. In our case, as there are so many images and each image is an 8 by 8 image, and our model will have to assess every pixel, our data processing will take quite some time. Though we are facing this problem, we are facing it on a smaller scale. Normally, to train a computer vision model to detect objects, it requires a lot of images and videos. Because if you want it to detect different objects, you need to give it many examples of the different uh, objects in different positions. Secondly, conversion of images into numbers. As we know, machines cannot understand pictures or words. They can only understand numbers. So how do we convert our pictures to numbers? Thirdly, there are many different ways and sizes in handwriting. Everyone writes numbers differently. So how do we train the model so that it is still able to recognize the digit? And finally, how to create a GUI or graphical user interface, which simply means how to create an app which can give the prediction of which digit has been drawn by the user. The way our computer vision will work is it will take the handwritten digits data, train the model by making it study the individual pixels of the 8 by 8 images, and compare them with the result or target variable, which is the actual digit represented there. Over time, the model will learn to identify digits and make accurate predictions. After which, we will create a web application and connect our model to it so that the predictions of our model can be accessed through the app. The deep learning algorithm we will be using is known as CNN or convolutional neural networks. The reason we are not using ANN or artificial neural networks is because they are slower and less accurate, because they don't have a filter or convolution function. We will go through CNN, but first we must understand what a basic neural network is and how it works. This here is a neural network. The circles are known as neurons or cells. The neurons in the dark blue rectangle are the input layer. The grey neurons are the hidden layer, and the green cell is the output layer. The way a neural network works is that it takes some input, passes it to a neuron, which creates a function. This function compares the variable with the variables with the target or output. Simply, it takes the features that we will be using to predict our main target feature. Once it has created a beginner equation, it makes some predictions. An equation as if, okay, and if our variable a increases by let's say 1 point, our output is changing from 0 to 1. So once it has such an equation, it makes some predictions. If its prediction based on the equation is wrong, it adjusts the equation based on the error. Every neuron has a different equation. Some equations are better than others and are given more influence over the output. And it keeps doing this until the neural network has a high accuracy. A neuron is made of two parts, the linear part and the sigmoid part. So, to give an example which can clearly show how the neural network works, let's take our house price prediction data. First, we will apply the linear part of the neuron. So, here is the variable on the basis of whom we will have to predict house price, area in square feet. Now what a neuron will do is it will take all the data points of this variable, area in square feet, and try to find a line that fits the data points the best. To find this line, it uses the equation of a line y equals mx plus c. Here y is the target variable, which in our case is price, M is the slope of the line, simply the value by which x affects y. So the slope of this line simply will tell you for how much change in x is y changing. So the more gradual or slow your slope is, the lesser and a change x will cause on y, and the more sharp or steep your slope is, the more x can change y. C is our y-intercept. Simply, a y-intercept is the value of y when x is 0. In this case, that value will also be 0, since a house with 0 area in square feet will have a price of 0. It then checks the error from each possible equation and finds which line has the least error. Error is calculated by subtracting the actual values by the predicted values. So for example, we predicted our price in the first data point to be 58 lakhs and our actual value is 60 lakhs. So our error is equal to 68 minus 58, which is equal to minus 2. Linear regression adds up the squared errors, takes the average, and that is called MSE, or mean squared error, of your line. And it does this until it has for every possible line until it has found the line which fits the data best and has the lowest possible error. The reason we use mean squared error is so that the positive errors and the negative errors don't cancel each other out, resulting into an imperfect model having better accuracy than it deserves. For example, in this case, mean absolute error equals minus 5 plus 5 equals 0. While if you use mean squared error, it will be minus 5 squared plus 5 squared, which is equals to 25 plus 25, which equals 50. However, there is a problem with this approach. But first, mean squared error will then, let's first look at the slope table though. This is the possible intercepts and slopes for every possible line, or at least some possible lines, and this is the error. So then based on this table, our model will decide which line is the best. So the one with intercept 0 and slope 1.6 has the least error, and the model will decide to use this line. However, there is a problem with this approach. If there is a data set like follows. In this case, we are predicting whether a person bought life insurance or not. Anywhere the line is at less than 0.5, the prediction is negative, as there is a less than 50% chance that the person will buy house insurance, which means it is 0. And in this case, we are misclassifying 5 points. Instead, if we use this model, we will only misclassify 3 types. This will also prevent from a new outlier changing the model. If a very old person took the insurance in this model, in trying to fit that person to the line will overextend. Its slope will decrease. This will result in some previously one classified data points to also become classified as 0. So you can see this there are 3 data points which are very close to this 50% line, right? And in that you can see there will be 1 point which will get misclassified if our 50% mark moves a bit to the right, which it will. If you put some very old data point near the age of 80, it will. So how do we get this line which cannot be shaken by outliers? Because even if you put one data point at 100, this line is already straightened out at 50, at 60 actually, and after that it's just going straight. So no matter what you do, it's not going to misclassify any previous points because of some new point. So how do we get this line which cannot be shaken by outliers and has better accuracy? You can see this line is only misclassifying 3 points. This line has a better accuracy because it knows that where the major trend in the data is shifting. It's shifting not at the halfway mark of age or like that. It's shifting at the age of 30. There is a sudden rise, after which it once again stabilizes out. So how do we get this S-shaped line? We will be using something known as sigmoid function. Sigmoid function converts all predictions of values between two values between 1 and 0. So simply it will take any value and return a value between 0 and 1. So how does it achieve this? It takes the output of our first line equation, y equals mx plus c, and then on the output of y applies another function, y equals 1 upon 1 plus e raised to minus y. Here e is Euler's number, which is 2.71, which means that its value doesn't change. It is always 2.71. So by applying the above function, it converts the prediction of our value to between 0 and 1. For example, if we had a value 80, our linear regression, so if we had a value 80 and our slope was 0.04 and our y-intercept was minus 1.53, our linear regression or linear equation for y equals mx plus c for the age 80 will give the result 1.67, which is out of our 0 to 1 range, because a person, if he buys insurance, should be given 1.67 is uninterpretable. It means that certainly that person will buy the insurance, but because of trying to adjust this point, our linear model will over adjust, like we previously discussed. So then we will apply the sigmoid function on this 1.67, which is y equals 1 upon 1 plus e raised to minus y. E is Euler's number. So it will become y equals 1 upon 1 plus 2.71 raised to minus 1.67. And the result of this is 0.96. We will also be using, and in this way what happens is, once you get the output of this sigmoid function, you give it to another neuron. This neuron will multiply it by a weight. These weights will define how much influence this equation that we have drawn here will have on our output, and then based on that there will be a prediction whether the digit is between which digit it is between 0 to 9. We will also be using tkinter library to create an application, as it is easy to learn and doesn't require too much in-depth explanation to create a simple application. We will create our tkinter app, which will allow the user to draw a number as he wants it, and then our model will identify it along with how much confidence the model has in its prediction. Here I have given an overview of how our machine learning model will work. We will first get our data from MNIST, which consists of 8 by 8 pixel images. Then implement train test split, our train will be 80% and our test will be 20%. Then we will scale our RGB values using we'll simply divide them all by 255, but as the max RGB value can be 256. Then we will scale them, which will convert all our values to of black pixels to 1 and white pixels to 0. Then we will train our CNN model, which will evaluate and then we will evaluate our CNN accuracy before making our tkinter application. We will get our CNN model from Keras, and we will create our application using tkinter. So how does convolutional neural network work? First, the input image is converted into pixels, so each and every pixel, and then the pixels values are scaled. So their scale means they are divided by 255, as that is the maximum value possible. So the RGB values for black are 255 and for white are 0. So by dividing all values by 255, we will end up with the black pixels converted to 1s and the white pixels converted to 0s. Then based on the digit we are searching for, our CNN will apply a filter to find a specific part of that digit. Then we will use max pooling to find our filter results. Then we will put our output through ReLU activation, which will give us our output or result. The way convolutional neural network works is that it detects a certain part, it searches for certain parts of the digit. So for example, if we wanted to check if the digit is the number 9, it will first search for the loopy circle or head of the number 9 before searching for the vertical line which is attached to the head, and finally the diagonal line at the base of the number. So every 9 has this loopy circle at the top, then there's always this straight line. This diagonal line isn't always there, but mostly it is present. So this is how our 9 will be detected. We will first identify the head, the body and the tail, and on the base, and if they are all there, then we will know that this is a 9. So how does our CNN actually search for these features? So for example, our digit 9 is here in the pixels which have their values scaled, and we have converted, so simply all the ones are black pixels and all the minus ones are white pixels. So now we will use this filter of numbers. So what this filter is doing is, it has a -1 or white pixel at the center and with ones or black pixels surrounding it, which is a circular shape of our 9's head. So first our filter fixes itself at the top left corner of the digit, and every number under the filter is multiplied with its filter partner. So in this case, if you see the top left corner, the filter will start here in this 3 into 3 area or space, and it will multiply every value in the digit or our image with our filter. So -1 into 1 plus 1 into 1 plus 1 into 1 plus -1 into 1 and so on. And then once it has added up, once it has multiplied all 9 digits, it will add them up. So in our case for the first filter, it got the value -1. Then it will take this and divide it by the number of pixels, which is 9. So -1 upon 9 equals -0.11. When we get the value 1, and the only time we can get the value 1 is when every number on our filter matches every number in the image. So that is when we will get the value 1, which will mean that it has found the loopy pattern. So what will happen is it will say 1 into 1, which is 1, plus 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 -1 into -1, which is also 1, and then when it adds them all up, it will become 9, and it will say, okay, 9 divided by 9 is 1, and we have found the loopy pattern filter. So here it did not find it, but in the second place it will find the filter. Why? Because you can see all the numbers are matched up. They will add up to 9, and when divided by 9 it will get the value 1. So here this table on the rightmost side is simply all the answers to all the loopy pattern filters. So this new table on the right will be derived after we have ran the filter on every possible row and column, going sideways by one column and downwards by one row. That's how it will generate this new table. And as I explained earlier, the cell with the number 1 on top is where the loopy head of 9 was discovered. Next we use max pooling. Max pooling is used to deal with computation of so if you have very large images and you have a lot of them, then your CNN will become very slow as it has too much data to process. So we will use max pooling. What max pooling does is it converts a 2 by 2 space into one cell, by taking the highest or max number from that space. In our digit 9 example here, the digit is moved to the left side. Previously, if you see, it was in the center of our image. Now it's on the left side. So you can see we first apply our convolution or filter to get the identification where the loopy head of 9 is, and you can see it's here at the top left corner of our image, right? Then it will apply ReLU function. So this second table that you see, where so many of these features are turned to 0, it has applied ReLU function. And then after this, it applies max pooling to get an image sized down. So it's converting the space of 4, which I've highlighted with this blue filter, to 1, because that is the largest value in this table. Then it will go a bit to the right, so 0, 0, 0 and 0.33. So the largest value is 0.33. So it uses that, and so it has scaled this 3 by 5 table into a 2 by 4 table. This reduces the total computation that our model has to do. In our tkinter application, we will be using our tkinter to create widgets the way our application looks, which I have already shown you, and it will use tkinter to connect the buttons to their functions, simply connecting the buttons to what they are supposed to do. Now let's get to the programming part of the project. We will be using Python and a software called Jupyter Notebook. First, we will import necessary libraries. Libraries simply consist of large blocks of code which are given names through which you can call them. Earlier, there were no libraries and you had to manually code everything yourself. For example, if you don't know the name of a person and want to talk about him to a friend, you will have to ask your friend the guy's name by giving a list of his features, how he looks, what he wears, where you met him, etc. And then your friend will recognize him and give you the name. When you start using the name, you no longer need to describe the person from head to toe or where you met him and all. You can just use that one word name and your friend will know who you are talking about. Similarly, when using libraries, you don't need to type in the whole code. You can just call the code from the library and use it. Here we are importing from Keras library, which is an important deep learning library with all the important deep learning functions. We are importing conv2D, which is simply short from convolutional 2D, and max pooling 2D, which is our max pooling, our dense, which simply attaches every neuron of a neural network or layer to every other, dropout, which decides how many neurons should be dropped every time we are training our data. The reason that we drop some neurons every time we are training is to prevent any neuron from overtraining on data. Flatten, we are importing to convert our 2D vectors to 1D. Now we are splitting our data into train and test sets. Our model studies on the training data by observing the x variables and how they are affecting the y variables. Then on the patterns it has detected, it makes predictions on the testing set. Then it verifies what the actual results are to find the error and adjust itself so that it can improve. For CNN, our data needs an additional layer, so we will have to reshape our data with an extra 1 in the end to add a layer. And we will also have to reshape our inputs to match the CNN size. Now we are converting our target variable, which has 0 to 9 values, because we are printing digits and there are digits from the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer is simply written as 0, 3, 4. We are converting those values to categorical variables. So we are encoding them, where every target will have a different column, and then based on the result, there will be a 1 or 0 in the column of that number. Here is an example of one hot encoding. So you can see when the color was red, color blue and color green columns had the value 0 because they weren't present, but color red had the value 1. Then if it was blue, blue had 1 and red and green were 0. So this simply tells you which value is present by using numbers instead of words. And also this helps because the machine cannot understand the words, these ones and zeros will help the machine understand. Then we will convert and scale our pixels so that the white pixels have 0 value and black pixels have 1 value. So maximum RGB values can be 255, right? And we are dividing our X train by 255 and also our X test. So black has an RGB value of 256 because all the colors are present in such quantities that they have darkened each other to black. And white is the absence of any color, so there is no red, no green and no blue, and our overall value is 0. So when 0 is divided by 255, it is 0. So white is 0, black is 1. Here we are creating or initializing our model. We first create our convolutional layer. We are using ReLU activation for the convolutional layer, right? Input shape we have already given. We are taking 32 inputs. Then we are adding an extra another convolutional layer with the same activation function. Then we are doing max pooling, which will our pool size we already discussed earlier will be 2 by 2. Then we are dropping 25% of the neurons before we flatten our array, which will come out. Because it will come out as a 2 by 2 array, we need to convert it into a 1 by 1. Simply it should 1. So rather than being a 2-dimensional array, we want it to be a 1-dimensional array. Give me a second. Yeah. So and then we are creating our dense layer, which will have activation softmax. Softmax simply means it will give the probability for every possible number. So the probability of it being 0 as 0, probability of if it's 9, then the probability of it being 0 will be very low, 10%, right? But instead of giving every variable a possibility out of 100, it combines all the possibilities and gives them all ratings out of 100. So what will happen is, for example, you have 3 possibilities, 1, 2 and 3. So if the answer is 2, rather than saying answer value of 2 is 90%, the value of 3 is 20% and value of 1 is 20%, so it's actually 2, it says the total values should add up to 100. So the total value should add up to 100. So the probability of it being 1 is 5%, 3 is 5% and 2 is 90%. So it is 2. Then we are checking our error, our model error and our model loss. We are also checking our model accuracy. Here we are saving our model into an mnist.h5 file and importing tkinter and numpy. Numpy is used for math and tkinter will be used for creating our application. Here we are defining our predict digit function. So whenever you pass an input in this function, see I have put it in brackets beside our define predict image the word the img, which is image. So whenever we pass an image through this function, it should give us the result, the prediction of which number it is. So first we'll have to resize our image to 28 by 28 pixels. So image is equal to image.resize 28 by 28. Then we have to convert our RGB values to grayscale, simply white and black. We don't want all the red, green and blue options because there are no red, green and blue options. When you write a number, there is only black and white. Then we are converting our image into an array before we reshape it to, because our convolutional neural network needs an extra layer, we will reshape it, get our RGB values converted so that the blacks are 1 and the whites are zeros using our image divided by 255 scalar. Then we are predicting the class, so we are saying model.predict image 0 because we will send only one image at a time. So and the first input in Python is always given the number 0 because 0 is first, then comes the number 1, and this will return np.argmax. Argmax means the argument with maximum probability. So whichever number has the maximum probability, that number will be returned with its probability, with the probability. So how confident is the model? Okay, 90% sure that it is the number 2. Here we are creating our canvas on which the user will write the number. So we are defining its width, height, color, and how our cursor will look. We want it to be cross shaped. Then we are defining the label, font, right? Then our button, so what text do you want on your button? Then we are giving it a command. This command will simply join the button to what it is supposed to do. There's also a button for there's a button for classifying, which is connected to the classify handwriting command, and there's a button for clearing your canvas so you can write another number, and that uh, uh, button is connected to the clear command. Here we are simply splitting our application window into 4 subsections. Here we are defining what our application will do if it is told. You can see here, if it is told to clear, if the clear button is clicked, self.clear underscore all. So clear underscore all function we are defining over here. It will simply delete everything on the canvas. What does it do if it's supposed to classify the handwriting? Then it will call the handle of the canvas. So simply this image prediction function which we defined here in the start, let me go there, this predict image, it is calling that function. Then we are getting the coordinates of our canvas, predicting and displaying our confidence score. Okay, so when our user is drawing the number, how is it going to be drawn? So r equals 8 simply means that the radius of 8 pixels. So if we say we want our radius to be 1, then only 1 pixel around the pen of the user will turn to black. But we want something which is easily understandable and easily interpretable. So we are saying r equals 8, so radius is 8. So 8 pixels around the user's pen will convert to black. Why are we saying 8? Because our images on which the model is trained are 8 by 8 pixels. So it is used to identifying 8 pixels at a time. And our pen is going to have the fill black, right? And we are doing main loop, so our model should constantly be able to classify new digits as they appear, rather than closing the application once one prediction has been given. So in summary, we have reduced the amount of space being used by using convolutional neural networks, conversion of images so that deep learning model can understand. So we converted our images to numbers using scaling and RGB values, different sizes and ways of writing the digits. We dealt with this problem with convolutional neural networks, which applies a filter in every possible area. And we created our GUI or application to give images to model for prediction. Overall, there are still improvements that can be made. Instead of a basic use case like handwritten digits, which has few which is not exactly used in the real world, we can apply this similar code on object detection, which has many use cases, and we can also take video live data and train our model on that, so that our model can analyze the video and the objects while it is actually happening, so in real time. But overall, this is a good beginner project, so that will be all.